Hopefully that worked. Does it say we're recording again? It says, okay, we're recording again. That just breaks it into pieces so that I don't run into trouble with YouTube with too long a video. So we're going to go ahead and compute this. So the way to handle that is you just compute 1/2 at a time. So we go 62.4. We do the plus one, 2.8. Yeah, that's an 8. Yeah, 2.861 times 5.6698 divided by square root of 20. So here, because we're just dividing by one thing, we don't have to worry about parentheses. I'll get that. Boom. 66.027. So I'll start right it here. 66.027 is the top end of that interval. And then I'll go second enter and come back here because it retypes that for you. And then do the minus version of it. So here's the minus. 58.77. So we're pretty sure, because the confidence level is 0.01, the long-term mean is between 58 and 66 approximately. So something like 60% or better, approximately. Any questions on that? Okay, let's move on then. So that's called a one-sided test because we're using just one tail. And we said that, where was it? Where did the actual test go? Oh, here it is. When we computed the p-value, we did one tail area. Since it was a greater than alternative, we took it the right-hand tail as our p-value. If it had been a less than alternative, we would take it the left-hand tail to be our p-value calculation. And when that's a two-sided test with not equal to, we take two tails. Whatever tail we came up with, we double that tail probability to make a tail on the other side the same as that one. That's how the two-sided test works, and we're just about to do that. Here it comes. It says here, environmental changes can upset the balance in predator-prey relationships. The scientist has been collecting samples of midges along the Arkansas River for some time. I guess midges are consumed by trout. I don't know, they're a little bug. People study them. Sticky traps are left for 24 hours and the number of trapped midges is recorded. The recent long-term mean, I guess per trap, has been determined to be 12.57 midges per trap. And we're trying to see if that number is changing over time. Last year, the results of 30 traps, so there's 30 traps here. We're wondering if those numbers reflect a mean of 12.57 or it looks like it's changed. I can't tell by looking. That's the cool part about statistics sometimes. I have no idea. If those look like, on average, they're going to be a lot different from 12.57. Is it bigger or smaller? I can't really tell. So I'm going to go ahead and enter the data here. I'm going to put it in list 2 because I already used list 1. Oh, this will take forever. Okay, I'll just do it. And then I'll just double check it because I'm sure did I get enough? There's 30 of them, okay. So the first one's supposed to be 11. I already messed up. Okay, 11, 15, 8, 14, 15, 6, fine. 13, 22, 13, 12, 19. Okay, coming down. 8. Okay, 20, 11. Scroll a little ways down. 20, 11, 12, 17, 16, 16. Next was 9, 16, 15, 26, 16, 12, 11, 15, 18, 9, coming up, 21, 10. Hey, I won except for the first one. Now we've got 30 values there, so we're not too worried about normality, but just to check, I'm going to do that anyway. I'm going to go to stat plot. I'm going to turn on plot 1. We're going to use list 2. And then that's done. And I'm going to hit graph. And we don't see anything again, I guess. See a couple dots. I will go to zoom stat. I hope it works. There it is. So that's wonderfully straight. I would have expected that to be quite that straight, so no worries. But even if it wasn't very straight, there's 30 values there. 30 values, the mean, no matter what you're sampling from, tends to be normally distributed and everything would be fine. And now we're going to do an analysis. We're going to need the statistics for list 2. So it says there, X bar is 14.2. So that's bigger than 12.57. Is it bigger enough? I don't know. We need S. S is 4.5667. All right, and then we're going to compute T, which is X bar minus mu. There's my phone. S over root. I may just grab that just really quick. No. I think they guessed I had a class. That was probably my my tech person telling me they fixed my Blackboard account because none of my videos are showing anymore. I thought, what'd you do? I didn't do anything. Maybe they fixed it. So 4.2 minus, what am I going to put here? Who should I ask? Oh, ask Rubio. What do you think goes there?
I'm not sure, to be honest with you.
Is this guy here? The long-term mean we're trying to get evidence against. I'll put 12.57 there. So if that's the wrong number, if this group wasn't sampled from something whose mean was that, I'll get an unusual value for T, a big value it looks like. And S, this is 4.5667, square root of 30 like that. And now we're going to crank that out. Okay, here we go. Parentheses 14.2 minus 12.57 divided by more parentheses 4.5667 divided by second square root 30. Get over, put another, there we go. You can't see it, I mean, or maybe you can. I got people over mine, but I think you can see it. There it is. So I hope I put parentheses on this side. Yeah, we're good. Okay, off we go. 1.95. So that's pretty close to 2. So we're going to be on the borderline of maybe being statistically significant, maybe not. That's sad, but that's life. The degrees of freedom here is 29. So I'm on my t-table here. Oh, it's 1 less, right? That's 30 minus 1. It's 29. N is 30. Keep writing, okay. And then we're going to come in here. Right there's 29. I'm zooming across this row here. And we're looking for the value we got. We got 1.95. So we want to find values on each side of 1.95. So 1.95 is between 2.045 and 1.699. And then we go upstairs to see what the tail probabilities are for those. So there they are, 0.05 and 0.025. So the actual tail probability is going to be bigger than 0.025 and smaller than 0.05. There's a lot of steps here. All right, so now I'm trying to find an approximate p-value based on everything we've found here. Let me fold this over. Is that enough? It is. Okay, there we go. So based on all those features, I need an approximate p-value. I'm looking for Jose. This is the hardest question I'm asking all day. Are you up to the challenge?
I think so.
All right. What do you think the approximate value for the p-value is? So it's between two numbers. It's a two-sided test. I'm giving you all the hints I can. We found those values in the tables. What do you think you do?
Subtract them, so it's 0.346.
No. Sad to say. We'll bother Alyssa. Alyssa, what about you? You up to the challenge? It's a hard question.
No, I'll try.
Okay, go ahead.
Sorry, give me a minute. I was gonna say what Jose said to subtract them.
Here's the story. The tail probability associated with our number. So we're thinking this. Here's t, okay? 1.95 is here. We found two tail probabilities here. One of them was 0.025, and one of them was 0.05. And here's our number here in the middle. So our tail probability is between those two tail probabilities. Fine, but it's a two-sided test. So we would like to take the two tails here. Where am I? Yeah. The p-value, oh no, I'm in trouble. Okay, the p-value is twice the tail probability. We don't have it. All we have is these guesses up here that are on each side of it. So what are we going to put down for an approximate p-value?
I have no idea.
So if we had it, we would just double it, right? So we said here that the p-value, the tail probability exceeds that. So we can double that to get 0.05. And it's less than that, so we'll double that to get 0.1. So those two values, the double tail probabilities, because it's a two-sided test, will be either less than and greater than the actual p-value. It's tough. I'll put it here. I told you it was a hard question. Between then 2 times 0.025 and 2 times 0.05, like that. Or a 0.05 and 0.10. In particular, the p-value exceeds 0.05 just barely. That's all the work we had to do to find out that we failed to reject HO. So mu equal to 12.57 is possible. So if you were the scientist, you'd go, oh, well, I was trying to show that the midge population had changed. It might have changed a little bit. It hasn't changed enough that we can prove it statistically. We would have to get a bigger number than this 1.95. It's sort of close, but not close enough. If we were expecting the midge population to have grown, then a bit of one-sided test, then we would have had 0.05 here. the tail probability would have been less than 0.05 and we would have rejected the null hypothesis. But since we had a two-sided test, we're just wondering, has there been a change? Those changes can happen two ways. So we have to do two tails to do the p-value calculation. And we got something bigger than 0.05. So we rejected it. We failed to reject HO. As far as we know, the mean could still be 12.57. This could just be random variation. I don't know, but maybe it says more here. I think it might. It says here, oh, that's calculator stuff. Let's do this with the calculator. Do I want to do it? I got the stuff in there, right? Let's do the calculator stuff. Clear this. Stat, tests, t-test, go. I've got data. The null hypothesis mean was, let's go over here. 12.57. We're in list 2. That's where I stuck the data. And then it's not equal to as an alternative. And then we ought to get a p-value slightly larger than 0.05, unless I made a mistake, which happens all the time. So there's the test statistic value, 1.9549. There's the p-value, 0.06, a little bit bigger than 0.05. And so that's life. We can't reject the null hypothesis. Ordinarily, if the p-value is less than 0.1, you might say there's some evidence to support your hypothesis, but it's not considered statistically significant, meaning could easily just be random variation. It's pointing the right direction, but it could just be random, so I can't really do more than that. I'm going to stop recording for a second.